All right. Yeah, a couple of equations on this test here. First of all, the square root equation. Square root 3x minus 17 equals 9. Just one of the most basic square root equations you could have. How do we go about doing that? Square both sides, yeah. In this case, I'm going to square both of the sides, because that will undo, essentially, it will undo this square root, won't it? The square and the square root cancel out, so we get 3x minus 17. Then over here we get 81. And then we can just solve that as needed. Add 17, 3x equals 98, divided by 3, 98 thirds. Now, contrast that to one, say, like x squared equals 40. A similar technique there, except kind of in reverse, isn't it? Here I'd do what? Square root it, yeah. Here I'd square root both sides. The only thing you got to remember is this is an x squared equation, so you need two answers. So how to get the two answers? Do a plus or minus in front of that 40, yeah. So when we go the opposite way here, so to speak, don't forget, if you use that square root method, you got to include the plus or minus. That doesn't. Now, some people try to go ahead and put a plus or minus over here, but that's not necessary here. It's only when you do the square root method. This is we're squaring both sides method, so that one doesn't get the plus or minus. It's just this side here when we square root both sides. So we get x equals plus or minus square root of 40, but that's 40 is 4 and 10, so I'm going to say that's 2 square root of 10. Plus or minus 2 square root of 10. All right, let me go back to another square root one here. Yeah, what you got to do, what you got to remember here on this, let's say the square root of 5x plus 16 minus 4 equals x. Hit a couple of little points on this one. One point on this is, yeah, if you've got a square root equation, you want to square both sides, but what do I have to do first before I can square both sides here? Got to get this square root by itself. And so that means I'm going to move the 4. I'm going to add 4 to both sides. So I get the square root of 5x plus 16 equals x plus 4. Then I can safely square both sides. Which the square and the square root cancel. So we get 5x plus 16 equals, and that'll be x plus 4 twice. Another point on that, yeah, there's my binomial squared again, so that's always write it twice in FOIL. So I've got x squared, 4x, and 4x, and 16, right? All those terms, all 4 terms. So 5x plus 16 equals x squared plus 8x plus 16, which brings up the next little point, and that is, how do I solve that? Yeah, this is now an x squared equation, and so the way I'm going to do this x squared, make one side 0. So in this case, I'm going to make one side 0, subtract 5x, and 16 to make one side 0, the left be 0. make it 0 equals x squared plus 3x, because the 16s do happen to drop out, which, now what can I do to solve that? A little bit of factoring. That has a common factor. In this case, I do a common factor of x, right? Whichever type of factor you need to. In this case, I'm just going to pull out an x, which makes it x and x plus 3, which would make each equal to 0, x equals 0, x plus 3 equals 0. That one's solved. This one's subtract 3. However, that brings up another point. I didn't make it on the last one, but those should really be checked. Those may or may not happen to work. The 0 worked. If I plug in 0 here, 0 there, well, that would give me square root of 16 minus 4 equals 0. Is that true? Yeah. So that one's true. What about 3? If I drop 3 in there for the x, that'd be the square root of, or negative 3, wouldn't it? So that'd be the negative, square root of negative 15 plus 16, and then minus 4 equals negative 3. Does that work? Square root of 1 minus 4, that's 1 minus 4, that's negative 3. It doesn't work. So in that case, they both work. Sometimes they both will work. May not, though. So we want to check them. All right. Square root. Let me go back. Let's do one of these. Another one of these. Yeah. Say I've got, all right, let's say I've got 4 x squared minus 7 equals 18. 4x squared minus 7 equals 18. No, that's not what I want to do either. Equals 16. That's what I want. 4x squared minus 7 equals 16. Okay. Yeah, this one, turns out this one I'm going to use the square root method on. And if I use the square root method on it, what would be my first steps here to doing that? If I want to do the square root method on it, I need to get x squared by itself, right? Because ultimately I want to square root both sides and do my thing there to use the square root method. And I can get x squared by itself, meaning I can get x squared by itself and then a number on the other side. So let's do that. Let's add 7. So we have 4x squared on this side equals 23. And then divide off the 4. So we've got x squared equals 23 over 4. So yeah, now I can use my square root method. Square root both sides. This is a... What else do I need there? I need a plus or minus. Yeah. Remember, this is an x squared equation, so I need 2 answers, and I get the 2 answers by putting in the plus and the minus in front of that square root of 23/4. So that says x, square root and the square cancel. That tells me x equals plus or minus. Now, do you see anything I could do there? Make it the square root of 23 over square root of 4, because then I can do the square root of 4, simplify it to be the square root of 23 over 2. Question or concern? Plus or minus? Yes. Any question or concern? All right, one other with the squared there. I can use that square root method on this one as well. say we got 4x minus 9 squared equals 26. 28. 4x minus 9 squared equals 28. I can square root method that, can't I? Square root both sides. Make this side be plus or minus is the only catch there to get the two answers. Now what happens is that and that cancels, so I have 4x minus 9 equals plus or minus, and that does turn out to be something simplified. 2 squared is 7. Break down 28 is 4 times 7, so I get 2 squared is 7. And then all I have to do is solve for my x. Add 9. So we get 4x equals, and then can't combine those, right? Not like radicals, so that would be 9 plus or minus 2 squared root of 7 is one way I could write it. And then divide off 4. So I wind up with x equals plus or minus 2 squared root of 7 over 4. And then, of course, one last little equation. Probably have a couple of these. Say I had 3x squared minus 9x plus 2 equals 10. 3x squared minus 9x plus 2 equals 10. Okay? What about that one? Well, that one's not square root method. That one's either, well, maybe factoring, but maybe quadratic formula. I think it's going to be quadratic formula. Yeah, we need to, but either one we do is going to have one side be 0, isn't it? So I need to subtract my 10 as the first thing there. Just thinking real quick here, factoring with the 8, 3. No, I just don't think it factors. All right. So that's what I meant to have anyway. Quadratic formula. However, you need to remember it there. Pop goes the weasel, whatever. Minus b plus or minus the square root, b squared minus 4ac, all over 2a. This is a little catchy, isn't it? All right. Helps you remember if you need to. All right. So what's my a, b, and c? A, of course, is 3. B is negative 9, and C is the negative 8. In that order, your A, B, and C. A is what times x squared, B is what times the x, and then C is the constant when you've got one side 0. So we're going to plug those in all to this nice little formula. So we do the opposite of B, so that's positive 9, right? Plus or minus then B squared, we're going to square negative 9. Negative 9 times negative 9, then minus 4 times the A, which is 3, times the C, which is negative 8. And then all over 2 times A, 2 times 3. What does that get me? 9 plus or minus the square root of 81 minus 9 times minus 9. Then minus those all out, that would be positive 96. Over 6. So we've got the square root of 177 here, don't we? Over 6. Now what you have to be watchful for is this. Be sure that thing asks if that simplifies. 3 is a factor, but I don't think there's any more to be done there. I think that one we can just stop there. You know, if it simplifies like our square root of 28, we would do that. This one doesn't. Probably will have at least one that does, but my makeup one here didn't. So that's what you want to watch for. Okay?